Okay, so let's test this again, see if it works. Let me get my pen. Okay, so I started this already and then found out it wasn't doing any sound. So let me do that again. This theorem says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Okay, notice we have a circle right here with two chords coming across, F, G, and J, H. All right, and then here is arc F, G that I've darkened in. All right, so if segment FG and segment JH, both of which are chords, if they are congruent in length, that means that these arcs are congruent in both length and measure. In other words, number of degrees and the length, the piece of the circumference. Okay? So, what that means, I'm going to go down here. We're going to not do this proof at the moment. I'll do that later. I want to get you working on the problems. Right here, this problem right here. Okay, again, I've already done this, so let's take a look at it. Find the value of x, justify your answer. All right, so we can see that FG and DE are congruent. And this, I'm going to do part of the justification here. FG is congruent to DE. Okay, so that makes FG, arc FG is congruent to arc DE. All right. And if that is the case, and we know FG is 116 degrees right there, then we know DE is also 16 degrees. Okay, what does that buy us? Well, angle X is a central angle, and the central angles are equal to the arc that is formed in measure. So that means X is 116 degrees. Ba-bam. There you go. All right. Next one. By the way, when there's a box and it says theorem in here, this is what's telling you what equals what. Okay, if a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. Okay, so we're looking at this picture over here. Sorry, let me get it out. Right there, we're looking at that picture. Okay, and I drew in that radii there. But what we see is diameter AB cutting chord XY, which means it is, and cutting it at a perpendicular, which means that these two pieces, XZ and ZY, are congruent. And that's what I've written that over here. If diameter AB is congruent to chord XY, then XZ is congruent to YZ, and arc XB is congruent to arc YB. Okay, so we have a practice problem here, which the first time I did it, I overcomplicated by a lot. But here we go. So measure of PQ is 49 degrees. There's PQ. Okay. It says find PT and the measure of PQR. Okay, PQR, well, if that's 49, that's 49. So we just add them together. 49 plus 49 is 98. All right, and then PT right here, if that's 6, then that's 6. There it is, 6. I was going for a radius. I was expecting them to find radius, ask me radius of the circle, you know, and all that more complicated crap that I always ask you guys. So, anyway, we will come back to the proof above later. let's check out what's next. All right, whoops, not gonna be able to use a Sharpie. I can see that right now. Darn it. Okay, switching. Okay, sorry for the shaking. I have my table with my writing on a separate table from my camera, and you know, it's just all nerd jury rigged here. Okay, in circle R, US equals 5. So US is right here. All right. SR equals 6 right there. Find TV. Okay, well, and explain your reasoning. Find TV, explain your reasoning. Okay, so we know that 5 and 6, we know that the radius of this circle equals 11. Right? Everybody get that? 5 plus 6 is 11. Woohoo! All right, so they want us to find SR. SR is... Wait a minute. Okay, no, sorry. They want us to find TV. All right, I was reading it wrong. Want us to find from there to there. So this is what I was going to start on the last problem. Right here, we know that R is 11. Therefore, this piece right here is 11. And if you can see it, we have a right triangle right there. Okay, I'm recreating it here. Right triangle, we have 11 and we have 6. Okay, and this is SV. Okay, and we know from the fact that this is a bisecting, radii bisecting a chord, we know that that piece is going to be congruent to that piece. So whatever I find here for this length, I will just multiply it by 2. Okay, and you can see a nice Pythagorean theorem problem here. 11 squared equals 6 squared plus x squared. All right, so 121 minus 36, because I just moved that over and squared them all in one step, is x squared. So what is that? That is a 5, borrow 11 minus 3 is 8, is x squared. Okay, so x, sorry, trying to avoid my Sharpie bleed through, x equals square root 85. All right, so I know that, and this is equal to SV, so TV equals 2 times radical 85. No need to get out your calculator, people. Right there it is, exact answer. Okay, so explain the reasoning. I just did as I went along. All right, so TV equal to 2 times SV theorem 2. Okay, so I'm going to stop this right here and see how the recording is.